All right, here we are, chapter 8. What we're going to do is just going to go question by question, start with number 1, okay? Whatever I don't finish in here, I'm going to finish in well, at least I'll attempt to finish it in the next class, okay? So I'll put the same review for both classes, and they're just go to your class and you'll see you'll see chapter 5 and 6 review, and it says what numbers each video is on. So if you don't want to look at every single one of them and you have problems like on number 7, just go to the one that's got number 7 in it. You follow me? So it's pretty easy for you. So this is chapter 8, and let's see what we got here. Now, this x should be an exponent. I just don't have time to go through and do all that. So really, it's y equals 2 to the x power. Yeah, the plus 2 is part of the x, isn't it? So, like that. So that's the way it should look. It's just kind of a pain to put it up top in this program. So anyway, that's the way it should look right there. Now, do you remember what the parent function looks like? It's been a while since we've done this. The parent function would be what? Y equals, let's use the same base, 2 to the what? To the x. Now, what would that thing look like? Let's get a little xy axis going here. Just to make it a little bit neater. Alright, so what does this look like? If you want, you could do your little chart, or you could do the chart in your head. Just put in -1, 0, 1 for the parent function. So if I put a 0 in for x, what's y going to be? 2 to the 0. What's 2 to the 0? It's 1. So at 0, we're going to go to 1 on the y-axis. What if we put a 1 in there? 2 to the first. So if I put a 1 in for x, what's the y going to be? It's going to be 2, so it's going to be right here. Now, is it just going to be a straight line like this? No, because if we put in a -1 in for x, what's 2 to the negative first? It's 1/2. So if I put a -1 in here, I go 1/2 on the y. You could put more numbers if you wanted to. If I wanted to put a 2 in there, what would I go up to? 2 to the 4th, right? So 4 would be up here like this, and you get the idea what it looks like. Does that make sense? So it looks like a nice smooth curve. Remember, this is the one where it gets real close to the x-axis, but never touches, and it just keeps on going up like that, and it keeps on going like that. A little squiggly, but you get the basic idea. Do you remember that one at all? So what do you think this stuff does to it? This stuff right here, that's in your function itself. So if it's in the function itself, it's changing the x value. What does that do to this graph right here? It moves it to the which way? Left 2 places. That's right. And what does this -3 do to it? It moves it down 3 places. So if we wanted to, let's do this in a different color. Let's go blue. Let's go, yeah, that's good. So let's go 1, 2, 3. So now my x-axis, right, because we did this with like the sine and cosine stuff, didn't we, with that vertical translation? It's very similar to this. So my x-axis now is down here like this. And let's just make this a straight line. Just makes it look a little bit neater. Put it about right there. So that's kind of like our new x-axis. Do you follow me? So, and what did this do? This moved it to the left 2 places. So this point right here, now watch. If this was my new x-axis, this would be my normal point, I guess, if you want to call it. But what's it doing? It's moving to the what? Left 2 places. 1, 2. So now it's right here, isn't it? Now, what did we do with this? Let's refer to this point right here. What did we do? When I went to the right one, I went up, what? 1 place. Do you see that?
Yeah.
So if I go to the right one here, I go up 1 here. Now, but if I went to the left one, I went down how much? Not 1, but a half. So watch, if I go to the left one, I go down a half. It looks like this. From here, if I went up, or if I went to the right, from this point, not from the origin, okay? From this point right here, if I went to the right 2 places, how far did I go up? I went up to the 4, which is what? 3 places up, isn't it? So if I started here and I went over 2, I go up how many places? 3 places, 1, 2, 3. Is that right? Right here, yeah. Does that make sense? So now it's going to look like this. Oops. It'll look something like that. A little sloppy. It should hit these points, obviously. I just missed them. But that's basically what it looks like right there. Okay? Gets really close to this line right here. Make sure you put that line. That's important. You can write it as a dotted line. Of course, you don't have colored pencils or anything. But you can just write that as a dotted line. And it gets really close to it. Just never touches it. And this just keeps on going. And it just keeps on curving up to infinity, really. Okay? Does that help a little bit? Right. We haven't done those in a while, so that's it. Now this is written kind of weird as well, isn't it? All right, this one's written kind of weird because I didn't put the exponents in there. When I copy and paste it from that other program, it doesn't write them as exponents. It's kind of strange. But what we have is this is all an exponent right here. So it's going to be 9 to the 3x plus 4 equals, excuse me, 243. And then again, this is going to be an exponent to the x plus 2 power. All right. So do you remember what we tried to do with stuff like this when we had the bases, when they look kind of weird like this? We tried to get them so that they have the same base. Do you remember that? So let's take a look. And a lot of times they rig these. Somebody have a calculator with me or with you? Punch some numbers in and see what we get. Well, we know what 9 squared is. It's 81. What's... Oh, it's 3 to the 5th. Okay, so it's 9 to nothing gives you 243, right? So that doesn't work. So when you look at this, and you'd think at first it would be 9 to something powered, but you put in it, you put in 9 squared, 9 cubed, 9 to the 4th, and you'll find out that you won't get a 243. You're like, okay, well, what could possibly be another base? How could I rewrite 9? I could write it 3 to something power, couldn't I? So I could write it 3 to the 2nd, and this is to the 3x plus 4. Paige, would you say was 3 to the 5th? Okay, so 243 can be written 3 to the 5th power. Now, how'd you know that? Did you know that just off the top of your head? I don't know, probably not. My guess is, so you use a calculator, just try a few things, right? Try 3 to the 3rd, 3 to the 4th, 3 to the 5th, until you see that this does actually come out the way it's supposed to be. So this is 3 to the 5th to the x plus 2. Now we have the same bases. Right? That's what we're trying to get here. Now, what's our rule? When I have an exponent, take it to another power, what do we do with those exponents? Multiply them together, right? So I'm going to take these and multiply them together. Now, you're going to have to do a little distributive property. So let's just do that in our head. You can put a parentheses there if you want to. So 2 times this right here is going to be 6x plus 8. And this, you do the same thing. You're going to multiply the exponents, so it's 3 to the 5x plus 10. Now watch, when the bases are the same, what can we do with the exponents? Just set them equal to each other. So just get rid of the bases, set the exponents equal to each other, and now it's just really simple algebra once you get to this point. Let's see, subtract a 5x from both sides, that's an x, subtract an 8, that's a 2, and there we go. That's how we do that. Make sense? Let's move on. Okay, let's look at number 3. I just wrote it down. So this is the same kind of deal. We want to try to get the bases to be the same. You look at this. This is a 1/4. This is a 16. And you're probably thinking, well, how in the world could I get the base to be the same? Well, what number kind of pops out to you that could possibly be the same base here? If you have 16, what do you think, Allie? 4, right. But this is not a 4. It's a 1/4. So I could write it, though, what? 4 to the negative first. Very good. So I could write that 1/4 like this. And then this is pretty easy to see, isn't it? That's just 4 to the 2nd power. Make sense? So you just have to know when I have a 1/4, I can make it, I could flip the fraction as long as I change the sign of the exponent. And I did that by making it 4 to the negative first. That's the same as 1/4, isn't it? So now we got the bases the same. So now I can multiply these together. And so again, that's negative m. What's that going to be? Plus 7. Good. And that's just 4 squared. Bases are the same, cross them out. So negative m plus 7 equals 2. You could do this a couple ways. You could add an m if you wanted to, subtract a 2. What's m going to be? It's going to be 5. That's all there is to that. That's the trick right there. Alright, here's a problem. It's a little bit different, but kind of the same, isn't it? Because look, I got bases right here. I got this 10 and this 100. So what do you think I'm going to make the base this to be? 10, yeah. Alright, now we do have a greater than. Might change things just a little bit. We'll see. So this, writing too fast. Let's try it again. So 10 to the x plus 3. We'll just write it like this. Greater than. Let's write 100 as 10 squared. And that's to the x minus 1. So we really haven't messed with this side just yet. Let's see what we're going to get here. Right? This is like the 3rd time today we've done this, isn't it? So what's this going to be? 10 to the what? 2x minus 2. So now, what do we do with these things? Works it just the same. Even though this is a greater than, it works the same way. The bases go. You just put the exponents in the same order. They're not technically being equal to each other, but they're in the same order. So we go x plus 3 is greater than 2x minus 2. All right, let's get x on the same side. Since we have an inequality, I'm going to put everything to the left. So subtract a 2x here. That'll go away. Subtract a 3. That'll go right here. So we've got negative x is greater than negative 5. But we don't want negative x. We have to, what? Divide by a negative. But when I divide by a negative, what do I do to my inequality? I change the direction of the inequality, so it's going to be x is less than 5. Okay?